What is probably the first two aspects that come to mind when you see those two terms? That is correct. And one of the aspects that is probably, I shouldn't say probably, but it can be, the most difficult part of this is going to be the reaction, especially when we get to the aromatics. Now, if you remember from your vocab terms, we had it's called an aromatic is a very stable ring structure. Because when we look at ring structures, we say cyclopropane, butane, pentane, cyclohexane, any one of those. But an aromatic is a very special six-sided figure known as benzene, and many of the compounds that are associated with organic chemistry build upon that very structure. Okay, so now we're talking about unsaturated hydrocarbons, meaning that somewhere there's a double bond that breaks very easily. It can hold more hydrogens or hold an OH group or hold a COOH group because these are unsaturated, unlike the alkanes. And some of these physical properties, okay, as you can see, the first three are gases, very similar to that of the alkanes. As we know, natural gas or methane, ethane, and propane are all gases as well. It's once you get to butane, these start to turn to liquids. And same thing with these compounds as well. And the formula is just a little bit different because since there's a double bond, there is no hydrogens on one of the ends. Well, there is, but there's only two instead of three. So the isomers of these compounds get to be a little more complex as well, just because of the double bond. We'll illustrate that in a moment. I think that's been the windiest weekend that we've had in quite a while, which is, where was that last year when we needed it? So the ground was so wet outside, of course. Holy cow, in about another week, you can say your school year's about 25% done. Is that it was set aside all athletics and other extracurricular activities. Is that yay or gosh, I wish we kind of slow down a little bit. Just on account of you would have more time to enjoy your last year of high school. Because there are other things that are probably entering your mind, and it gets hard to block some of them out, but we'll get through it. College applications, financial aid applications, maybe none of that has been started yet. ACT tests, is anyone taking those yet again this year, or is that a distant memory? Okay, is that another? Well, hopefully we get you somewhat prepared for that. We do our best. Okay, so I just want to do this one and then some on this slide here, and then we'll wrap that up. And I didn't have a whole lot to do today, just on account of got some other work that pertains to this class as well to try to get caught up in. But hopefully one advantage that I think that you people, if we choose to take advantage of that, and that's what you're doing in here, taking advantage of the opportunities given to you with some of these higher level classes. Are they difficult? Yes. Are they going to serve you a purpose? Well, we hope so. And is it going to allow you to be successful next year, 2 years from now? Again, we hope so. And it's one of those aspects we just try to make the best of the time that we've got. Because said another week, that's almost 25% done. Just off the top. So then people will be gone. Yes, they're out of my hair, which nothing up there anyway. So it's not like it's that big of a deal. Okay, so then, like I said, I'm gonna do a couple things up on the board after this, and then we'll be done for today. Because this will make more sense when we're talking about these isomers when it comes to double bonds. We can read all we want. Same thing with naming those alkane derivatives. It's easy to read the rules of how you do that. Until you actually apply them, it probably doesn't make much sense. Same thing where maybe some of your, and I still don't understand this, into the net with volleyball. If you were to look at the actual terminology, I'll bet you that would be really confusing for you to actually read the volleyball rule book. But then when you actually see it in during a game, well, yeah, that makes sense. And maybe that's a call. Is that consistent? Do you think it's maybe called consistently, but is it called consistently fairly? See, I don't know. That's why I'm asking. Your opinion would be what? Yes. Consistent? Okay. See, yeah, I wouldn't know. All right. Okay. Yeah, that's where I want to stop for today. Does everyone have this information that wants it? Okay. We're going to write a couple things up on the board, then that will be it. So write this down. Don't write this down. Whatever. Okay. So what we mean is, notice that with the saturated hydrocarbons or that of the alkanes, you had C and H. Now you don't need to write this down because we've been applying this. Okay. Okay. And then when it comes to these alkenes, notice that we've got C and H2N. Okay, so someone pick a number between 3 and 6. Either that's hitting the button too quick or just see if everyone's listening. And 7 is the first one that I think I heard. You said 5? Okay, yeah. All right. So if we were to do that for the alkanes, notice here's your 5 carbons. Okay, and then we put our hydrogens in, so we already know we're up to 10. And then there's 11 and 12. We put 5 in for this. Okay, that's 10 plus 2 more gives you your 12. No one would argue with that. But when it comes to these unsaturated hydrocarbons like that of the alkenes, if we put 5 in for that, okay, 1, 2, 3, 4, 5, okay? So we know that there's a double bond located somewhere because we're telling you that. Here's our double bond. So we can put our hydrogens in here, but we're supposed to have 10 because we're putting 5 in for N, just like what we did there. So we've got 2, 4, 7, okay? Here's 8 and 9, and then here's your 10th one, okay? Because remember what we said when it comes to these unsaturated hydrocarbons, we don't have 3 on the end. We're taking 1 away from here because of that double bond, because it's unsaturated. This bond breaks very easily, okay? Now, with the last thing that you wrote on your paper, it was talking about that the isomers of butene as opposed to butane, okay? So if I was smart, I wouldn't erase all of it. Just left that pentane up there. But if we're talking about butane now, okay, how many isomers do you think you can come up with for butane? And this is where we said the smaller the number, if you had to give them all for octane, that would be horrible. We had to do maybe 6 or 7. If you had to do all of them for decane, that would be, of course, even worse. But on your exam, notice you had to do it for hexane. And there were 4 derivatives for hexane. Okay, so the smaller number that you get from 6, now we're down to 4. Now there's even less isomers. So do you think there's 1 or 2 isomers? There is only 1. Okay, so what that means is we're just going to pull 1 off the parent chain. That's the easiest way. And there it is. Okay, there's our 4 carbons, and we still have our 10 hydrogens. Yeah, 3, 6, 7, and 3 more gives you 10. There are no more isomers because if we move that methyl group either one direction or the other, it's part of the parent chain, or if you put it on top, it's still the same compound. But if we deal with that of butene instead, okay, there's more than just 1 isomer. Okay, this is saturated, it only has 1. This one actually has 2. Okay. And if we call this butene, which we will, if you really, really wanted to be specific with naming this compound, what you have now is fine. But if you really wanted to be specific, what do you think you could do to change that? And it has something to do with, I always use this as an example. Do we put this 1 here? It's not wrong if you do, but it's just understood that you have 1 sulfur atom. So if we write butene here, it's just understood that where's that double bond located? After which carbon? The first one, just like this as an example. So you could write 1-butene if you wanted to. It's not wrong, but it's just not necessary. So what do you, and this is one of the things I could just tell you what the 2 isomers are, but then we're not making you think. And maybe since it's a Monday, maybe that's what you would prefer, is not having to think. What, in your estimation, do you think is the easiest way to make an isomer from 1-butene? The clue is right here. Yeah, because if we have 1-butene, the simplest thing to do, move it next door to 2-butene. But we have to do that correctly because now we're removing that double bond. Okay, now that is a single bond in there. He needs another hydrogen. Okay, we're not quite there yet. There's one more thing we got to do. Something with this carbon right here. It's got 5 bonds right now. So let's go ahead and take that one off. Okay, so we went from 1-butene to 2-butene. Okay. And the last thing you can do is put a methyl group on there. That would be the last thing that you can do. Okay. And I think there's probably a little tiny glare on there. That's probably kind of annoying. Okay. And then the last thing we're going to do, we're going to pull this methyl group off. Okay. And it's no longer going to be butene anymore. Well, what about if we put this methyl group up here? Would that be all right? You're doing what we said we should do, but can anyone see a problem with this? It's part of the parent chain, which means what would you name this, do you think? Yeah, well, now we're back to butene again, because now it's after the first carbon, 1, 2, 3, 4. So when you say part of the parent chain, you're exactly right. So if we can't put that methyl group here, where must it go then? And we can't put it over here, because then we still have 2 butene. So if it can't go on the left side, it can't go on the right side. It's got to go right on the middle. And then now we've got 2 methyl, but not butene anymore, because how many carbons are in your parent chain? So no, it's no longer butene anymore, but rather, what's the prefix for 3 carbons? Yeah. So now we've got 2 methyl, 2 propene. So there's a little more information that you have to establish and write with these. Because one, you have to name any derivatives and where that double bond is. Okay. Like we said, in this case, we've got 2 methyl. And you correctly said propene. All right. Left outside, we good? Right outside. And right middle, left middle. Awesome. That's all I got for today then. We will do a little bit more tomorrow. All right.